Good evening guys. In this video we will see how to draw the projection of solids when the axis of the solid is inclined to any one of the planes. Okay. So in this video I am going to draw the projection for this question number 2 and 3. Okay. The question number 1 and 4 I already drawn the projections. I posted it in my YouTube channel. Okay. I shared the links for those videos in my description box. If you want you can use it. So now we will take this question number 2. A pentagonal pyramid of base side 30 mm and axis length 60 mm is resting on HP on one of its base corner with its axis parallel to VP. Draw its projection when its slant edge containing the resting corner is vertical. So now we will see how to draw it in the software. Go to the software, do the basic settings, the units, set it in millimeters, click OK. Then set the limits. Limits I'm taking the size of the A3 sheet, okay, 0, 0, 420, 297. Then type zoom and enter all. Now first draw a reference line for a length of 400 mm. So you can take this length roughly. I'm taking it as 400 mm. And then using the text command, so you give the name to this reference line and also mark the vertical and horizontal plane. So this is X and this is Y, and above the line it is VP, below the line it is HP. Now we will start the projection. Okay, see the question. It is given that the axis is parallel to VP and the pentagonal pyramid is resting on HP. Okay. For this condition, the true shape you will get it on horizontal plane. Okay. The true shape, that is the pentagonal shape, you will get it on the horizontal plane. That means when you see from the top, you will get the true shape. So first you have to draw the true shape, and then you have to get other projections. So next, one more condition they are given, that the slant edge containing the resting corner is vertical. So first we will draw the true shape. Okay, here the true shape is pentagon. So type polygon, enter the number of sides as 5, select the edge method and draw the pentagon like this. Select the first point on the workspace, and then for the second point you mention the length of the side, which is 30 mm. So then you can move this pentagon close to that reference line. It is very far from the reference line. So select the move option. So I'm moving close to the reference line. Okay. So the distance between this reference line and the pentagon is a rough distance. Okay, they didn't give it in the question, so you can take it roughly. So you try to place the pentagon close to that reference line. Not only pentagon, whatever the size you are dealing with, you try to place close to that reference line. Okay, now after placing the pentagon, you give names to all the corners. So I'm taking it as A dash, B dash, C dash, D dash, and E dash. Then now, to get the front view, okay, this is the top view. To get the front view, you have to project vertical lines from all the corners of the pentagon. So before that, what you do, it is a pyramid, okay, it is a pyramid. So if it is a pyramid, what you have to do, you have to connect all the corners to the center of that shape, okay. Here the plane figure is pentagon. So from all the corners, you connect to the center of the pentagon. This is only for the pyramid. Okay. Now you project vertical lines up to this reference line from all the corners. So if it is a pyramid, you have to project vertical line from the center of the pentagon also. So from center also you have to project one line. So whenever you are dealing with a pyramid, so you have to project one line from the center of the object, a given object. Now from the center line, you mark the axis length, which is 60 mm, and then from all the projected lines, you connect to this common point at the top, which is called as apex. So once you connected all the points to a common point, now place this over at the top. Okay. Now you have to mark the corners at the bottom also in the front view. Okay. The bottom you will have this pentagon shape, so you have to mark the corners. Again, use the text option. Okay. Here the corner A is a visible one, whereas E is the hidden one. So you have to mention this corner E within the bracket. So A within the bracket you have to mention E. Next one, B is the visible, T is the hidden. So within the bracket you have to mention D. The next one is C. Center line, you change the line type. Center line should always represented using this big dash, small dash, big dash line. Okay, we call it as a center line. Go and load the different types of line. Okay. To mention any hidden edges, you want to select the dash lines. To mention center line, okay, we'll have a center line type. Select all the three types. Okay, click OK. Once you loaded them into your this work module, then select the center line and change to this center type. Now we will come on to the question. So they are given that one of the slant edge, the slant edge containing the resting corner is vertical. Means one of the slant edge, you have to make the slant edge into a vertical one. So for that I am going to first select this front view, this triangular faces along with all the corners and the alphabets. Select copy and move it to right. And you take C as the base point, move to the right, and place it. So now we have to find out, okay, to make this one of the slant edge. So I am going to make this edge O2C edge as I'm going to make that edge OC into a straight one, to a vertical one. For that I want to know by how much degree I want to rotate that this entire rectangle. So I'm going to measure it. So I'm going to put a vertical line. So I'm going to measure this angle between the slant edge and the vertical line. So it is 23 degree. So I have to rotate this entire triangle by 23 degree about this point C. Then this slant edge, OC slant edge will become a vertical one. So now again select all the triangle along with the alphabets, click rotate, select C as base point, and now you have to give, so now I want to rotate this triangle in clockwise direction, so, but the software will rotate it in anti-clockwise direction if you specify a positive value. So I am going to give minus 23. I want to rotate it in anti-clockwise direction. Now it is rotated by 23 degree. Now you see the slant edge become a vertical. Okay. Now you project vertical lines from all the corners from the front view. Okay, rotated front view. Similarly, you want to project lines from the top view from all the corners. So once you projected lines from both the front as well as the top view, now you start marking the corners, okay, using the point option. Select PO, press enter. Then you have to identify this A line from the top view and A line from the front view. Okay. So both these lines are meeting at this point. So I'm going to put a point here. So before that, you change the point style. Okay. The default style is a point. You change it to some other style. Set size in absolute units and decrease the size to 4. Okay. Set the point size in 4. Okay. Select set size in absolute units. And then now you can see the point style changed now. Now similarly put a point B, C. Okay, this is point C. And this is point D, point E. So after putting the point, now you have to connect all the corners. Before that, this point, you will have two corners. Okay, C and O will fall on the same point. Corner C and this common point, apex point, will fall on the same line. Okay, first connect the bottom face, okay, which is a pentagon. Okay, start from A. So before connecting the pentagon, you will give the names to all the corners. Okay, this is A1 dash, B1 dash, C1 dash, D1 dash, and E1 dash. After giving the name, now you take a line, and this point is a common point. Okay, this point you will get both corners C as well as this common point O. So now take line, start from A, connect all the corners. So now if you see the front view, from all the base corners, a line is connected to this common O. So similarly, you have to connect from all the corners to this corner O. Okay, already the line is connected from D and B. So now you have to extend a line from E to O and A to O. Now after connecting all the edges, now select all the edges, increase the line thickness and change the color so that you can differentiate it from the rest of the construction line. So now we'll move on to the next question, question number 3. A cylinder of base diameter 50 mm, okay, it is not 500, okay, it's 50 mm, and axis length 70 mm is resting on HP on a point on the circumference of the base with its axis inclined at 50° to HP and parallel to B. Okay, whenever you are dealing with the inclination problem, the first thing we have to make some assumption, okay, to get the true shape. In any inclination, we will not get the true shape. Okay, so first we are assuming there is no inclination, it is perpendicular. Okay, in case of solid, you have to assume there is no inclination, it is perpendicular to HP. Okay, if it is perpendicular to HP, you will get the true shape on the horizontal plane. So first you have to draw the true shape on the horizontal plane. Here the true shape is a circle. Okay, cylinder will have a circular shape at the top as well as at the bottom. So here first you have to draw the true shape at HP. So the true shape is a circle. Go to the software. Okay, first put a circle on HP for a diameter of 50 mm. Means radius is 25 mm. So mention the radius 25. So before projecting vertical lines, here the circle is not having any corners, okay, any defined corners. So to create corners, so we have to divide the circle into some equal number of parts. Okay, first put a vertical line, first put a line connecting the center of the circle to the base point of the circle, that is base point at the circumference of a circle. So take a line, start from the center of the circle and move towards the base point of the circle. Now you select this polar array, go to the array and select polar type and select this vertical line as the object. Select only this vertical line, don't select the circle, press enter. Now it asks you to specify the center point. So specify the center of the circle, click the center of the circle and go to this left top corner, you can see item number. You change to 8, okay. The default value is 6, you change to 8. And click close array. Now you see the circle is divided into 8 equal parts. Now you got 8 corners. 8, not 8 corners, yes, 8 corners. Now you give names to all the 8 corners. Start from A. A dash, B dash, C dash, D dash, dash, F dash, D dash, G dash and H dash. Now you project vertical lines from all the corners of the circle. So now in the front view you will find a rectangular face. Okay. So before drawing the rectangular face, I forgot to define this base corner. Okay, I defined only the top face corners. Okay, since it is a cylinder, it will have two faces, one at the top and one at the bottom. Okay, both are of same shape. Okay, similar kind of shape, which is a circular one. Okay, I defined only the top corners, top face corners. So bottom face corners, I am taking the alphabets P, Q, R, S, T, U, V, W. Okay, so this is P dash. So when you see from the top, okay, this bottom face corners are hidden corners. That's why I'm putting within the brackets. After marking on the corners, then we have to project this. You have to mark this height of the cylinder, which is given as the axis length at the vertical plane at the front view. So I defined all the bottom face corners. Okay. Now take line and mark that axis length. Okay, there is the height of the cylinder at the top, sorry, at the front view. Okay. So the axis length is 70 mm. From all the projected lines, draw a vertical line for 70 mm. Then you connect all the vertical lines at the top. Okay. At the bottom also you have to put one horizontal line, okay, representing the bottom face. Now you define the corners at the top face. Okay. So again use the text option. This is corner A. Corner A, and this one is corner B within the bracket H. Okay, B is the visible corner, H is hidden. Next one C within the bracket G. Next one D within the bracket F, and the last one is corner E. Similarly, you have to define the bottom face corner also. Start from P. Okay, Q within the bracket W. Q within the bracket. And then R within the bracket B. The next one is S within the bracket U. The last one is corner T. Now we will go on to this question, this inclination. Okay, the inclination given in the question is, it is inclined by so before that I will put a point. Okay, these alphabets are a little bit confusing. Okay, so I will put a point, the bottom as well as the top face. As it is having more number of corners, as we defined more number of corners, so it is little bit confusing. So I put a point, the corners, then I will extend this reference line and this shift this y to the end of that line. Now we will go and mark the inclination. It is given that 50 degree to HP. Okay, this 50 degree I have to mark it on VP. The axis is making 50 degree. So go to the software. So first you select this rectangle which you drawn on the front. This is which I draw on the. I will select this rectangle along with all the corners and select copy and move to the right. Okay. Select T as the base point. Move to the right. So now what I'm going to do, again I'm selecting and I'm going to rotate this about this point T by 40 degree. Okay. So I will explain why I am rotating it by 40 degree. Okay, so I want to rotate it in clockwise direction, so I'm putting -40. So I didn't put any bottom face, so a line for the bottom face. So I take a line and put a line connecting the representing the bottom face. And now using the extend option, you extend this center line up to this reference line. Now you measure this axis angle. Okay, it is making 50 degree with that reference line. It is 50 degree. And this one is 40 degree. Okay, which I rotated this rectangle about T for 40 degree. Okay. So this I take I took 40 degree by this, assuming that it is a right angled triangle. Okay, any triangle. Okay, it is a right angled triangle. Okay, the sum of internal angles of the triangle is 180 degree. That corner is making 90 degree and this one is 50 degree. We want this one to be 50 degree. Okay, so if you add 90 plus 50, it is 140. 180 minus 140 is 40. So I rotated this about T by 40 degree. So this axis will automatically will become will make 50 degree with this reference line. Now you project vertical lines from all the corners from the front view, from this rotated front view. So now projected vertical lines from all the corners. Similarly, I have to project vertical horizontal lines from the top view. So now after projecting vertical lines both from the front and top view, now we have to mark the corners. First I'm marking the top face corners. Okay, find out the A line and mark the point A. Likewise B, this is C, D and E. This one is F, G, and this one is H. Okay. Next I'm going to mark the bottom face corners. Okay, start from P. Okay, sorry, that's not P. This is P line, and this is that is Q line. Okay, sorry, this one is that is point P. Q is R. This one is S, and this next one. Okay, so, this one is T, and this one is U, V, and the last one is W. Okay. So now you take spline and you connect all the points in the both top as well as the bottom face. Spline. So first I will connect the top face corners A, B. Next connect the bottom face corners. Now after connecting both top and bottom face, now we have to connect this bottom face by the longer edge, bottom and top face by a longer edge. So I'm connecting these 2 points. So take a line. I'm not getting it rightly. I'm not able to fix it at exactly at that point. I'm deleting. I'm redrawing it. Similarly, you want to put other line